Hi, my name is Alfredo Palios. I am a college instructor and a senior high school principal at Aurora State College of Technology, located in the northern part of the Philippines. Let me acknowledge my co-authors who contributed to this study, Mr. Macario Tobe Jr. and Ms. Crisel Joy Picard. We entitled this paper Long Distance Lab Affair: The Influence of Physics Laboratory During Modular Class on Achievement and Metacognition. This study is conceptualized in view of the importance of performing laboratory experiments in physics which have demonstrated impeccable significance during F2F classes. Because most classes in basic education and even in higher education are modular, self-paced, and conducted at home, doing lab poses difficulty due to lack of supervision and materials. However, we are curious whether this difficulty outweighs the importance of doing labs even during modular distance class. We look for inquiry-based learning as applied in physics in both virtual and physical labs.
Physics is a science that is studied by experimentation. Concepts were discovered through careful observation and careful study of real-world experiments. Inquiry-based learning is a learning theory that is based on constructivist and socio-constructivist theories. The theory encourages active learning, also known as learning by doing. The inquiry method entails posing guide questions to students while allowing them to search for their own solutions to the given problem. One major consideration for the teacher is activating the student's schema so that the students can recall their prior knowledge and apply or supplement it in their current situation. Inquiry-based learning is also frequently described as a cycle, which implies the formulation of a question, investigation, creation of a solution or appropriate response, discussion, and reflection in relation to results. The model of the inquiry process adopted from Justice et al. Is depicted in the figure below. Guided inquiry is the third of the four levels of inquiry where students solve a teacher-posed question by experimenting. In contrast to traditional labs, there are no procedures and materials provided in guided inquiry, which makes it more engaging physically and in the mind. Thus, the study's goal is to compare the effectiveness of guided inquiry, virtual and physical lab, to the use of pure modular teaching approach, as well as determine its effect on students' metacognition and performance on a series of physics achievement tests. Figure 3 depicts the conceptual framework of the study. Specifically, our study aims to determine if there is a significant difference in the physics achievement of senior high school STEM students when exposed in the following distance learning modalities: module-only class, virtual laboratory plus module class, and the physical laboratory plus module class. Second objective, determine if there is a significant difference in physics achievement of male and female students when exposed in different learning modalities. Third, determine if there is a significant difference in the physics learning metacognition of senior high school STEM students when exposed in different learning modalities. Number 4, determine if there is a significant difference in physics learning metacognition of male and female students exposed in different learning modalities. Our study follows the design of repeated measures and the pre-test post-test design. The participants are the grade 12 senior high school STEM students of Aurora State College of Technology. For the instruments, in virtual lab, we used PhET interactive simulations, specifically in projectile and law of acceleration. To measure metacognition, we use SEMLI-S, or the Self-Efficacy, Metacognition, and Learning Inventory Science, developed by Thomas et al. The topics covered in this study are: for modular class, uniform motion, uniformly accelerated motion, and freefall motion. For VLM class, the topics are projectile motion and the law of acceleration. For PLM class, the topics are laws of interaction and inertia. The module used followed the self-learning kit format, which contains introduction, objectives, procedures, summary, evaluation, and references. For procedures, the sequence follows ADIDAS, which stands for activity, discussion, input, deepening, application, and synthesis. To measure physics achievement, we use 3 physics achievement tests. First, Part 1, composed of 25 multiple choice questions, whose average difficulty index is 0.486. Second is Part 2, also composes of 25 multiple choice questions, whose difficulty index is 0.493. Lastly, Part 3 is also composed of 25 multiple choice questions with an average difficulty index of 0.478. For statistical analysis, in objective number 1, we used paired samples t-test because data are normally distributed according to Shapiro-Wilk test. We also performed gain score analysis using the non-parametric equivalent of ANOVA, the Kruskal-Wallis test, because the dataset failed Levin's homogeneity of variance test. For the second objective, we used students' t-test due to the equality of variance across its datasets. For the third objective, we used the non-parametric equivalent of repeated measures ANOVA because the datasets are not normally distributed. Lastly, for objective number 4, we use Mann-Whitney-U because the datasets are again not normally distributed. For the results, from the figure, we can see that all post-test scores are higher than the pre-test. Based from DepEd's standard of mastery level, module-only classes did not show improvement for the test scores where both were only at average mastery. On the other hand, VLM classes improved from average mastery to moving towards mastery, while PLM classes improved from low mastery to average mastery, both implying that physics instruction is better when accompanied with laboratory experimentation. Results of comparing the mean percentage score between pre-test and post-test across its learning modalities are presented in Table 1. All teaching techniques used during the entire study resulted to statistically significantly higher post-test scores than pre-test. Pre-test scores are surprisingly low. This is especially true for the laws of inertia and interaction, where pre-test is at low mastery. I noticed that during the pre-pandemic face-to-face classes, many students can recite the third law as, for every action, there is always an equal but opposite reaction. Though relatively fewer, they can also recite the first law as objects at rest remain at rest, while objects in motion remains in motion unless acted upon by an external net force. But when asked to explain what those statements meant, they either do not answer or would simply paraphrase. Clearly, memorization is far different from comprehension, which has no place in studying physics or science in general. All modules used effectively increased students' knowledge. Modular teaching approaches have shown effectivity in the past because in this approach, students' learning interests grow and they tend to learn independently at their own convenience of place and time. It is also interesting to know whether the addition of virtual or physical lab augmented the effectivity of these modules. Kruskal-Wallis analysis showed that at least one of the gain scores is statistically significantly higher than either of the two gain scores. Pairwise comparisons showed that gain scores in VLM are significantly higher than gain scores in MO, while comparison of gain scores between PLM and MO and PLM and VLM showed no significant differences. Virtual labs have been deemed complementary with physical labs during face-to-face classes, similar to the findings of Ogham and Zicari, Bajpai, and Oral. The current study had shown again that science learning is more superior when accompanied with laboratory experimentations than teaching with lectures alone. In this case, purely modular class. Conduct of distance physics lab was hinted by Musvi et al. That might also be a possible alternative to an in-person lab, as they found to be of equal significance. In the current study, however, conduct of distance virtual labs shown better improvement of pretest scores than the physical labs. This may be attributed to the fact that this was implemented during distance classes without any physical teacher supervision. As such, simulations in the virtual labs were easier manipulated, and the results showed clearer trends and relationships among variables than physical experimentations where error is likely to occur. In this figure, we can see that males always outscore females with gain scores. However, in this table, comparison of scores showed no statistically significant difference. All scores were statistically equal, which means that all the strategies used were gender fair when it comes to their test scores. A fast-growing consideration in teaching that aims to provide equal chances for male and female students to learn. Equal increase in science achievement after laboratory activities among male and female students have also been shown by Ogham and Zicari in 2017. For metacognition, the figure presented shows an increasing metacognition starting from module up to the PLM classes. Friedman tests showed that at least one of the learning modes under study has statistically significantly higher SEMLES scores. Consequently, we performed pairwise comparison of its metacognition, which I present in this table. Bonferroni correction for multiple comparisons showed that only the SEMLES score for PLM was found to be statistically significantly higher than the pre-module scores. No other significant differences were observed for MO and the VLM methods, which means that only a physical laboratory plus module method improves students' metacognition in learning physics. In physical labs, students had to design an experiment using materials available in their homes. Hence, they are more engaged compared to simply manipulating a virtual simulation in VLM, making them more aware of their learning processes. Though metacognition may be taught by direct instruction, it may also be improved through exposure to some conditions that makes one aware, such as writing of reflection. In this study, it is shown that metacognition may also be improved through a conduct of physical labs similar to the findings of Sandi Urena et al. The SEMLES scores across learning modes were also compared among sexes. Their scores are shown in figure, where we can see that males have higher metacognition than females. The trend also shows increasing scores, except that in females, metacognition drops during MO classes. We performed statistical comparisons between these scores, and the result is presented in the table. Metacognition for male and female participants were statistically equal across pre-module, VLM, and PLM inventories. However, after MO classes, male participants significantly outscored their female counterparts. Knowing that females can self-score their metacognition as well as males only shows that the significant difference in metacognition after MO classes is because males improve better than females at this learning mode. Most classes in Philippine schools are purely modular. This poses physics learning inequity for the sexes, with females at a disadvantage when it comes to improving metacognition in learning physics. Just another good reason to pursue laboratory even during distance class. For the conclusion, each teaching strategies have their own strengths and weaknesses. In this study, it was found out that all techniques are effective in increasing achievement scores. Gain scores analysis showed that BLM demonstrated significantly higher score than MO. Metacognition seemed to have improved only during the PLM classes. Although all strategies showed no gender bias in terms of improving physics achievement, module-only classes seem to favor male over female students in developing metacognition for learning physics. In addition to numerous literatures showing the necessity of doing labs in teaching physics, the current study had demonstrated that even during modular distance class, conduct of labs must be pursued. Convincingly, a clear distinction between the role of virtual and physical lab on students' development has been established. Recommendations: even during distance classes, physics teachers are recommended to conduct laboratory experiments employing guided inquiry approach, where students engage by solving a prompt. Both virtual and physical labs must be used equally well, since the latter increases physics achievement while the former in metacognition. Even when the pandemic is over and face-to-face or in-classroom classes resume, it is recommended that modular class coupled with lab is offered as an alternative since it showed potential in improving achievement and metacognition. Caution must be made when teaching with pure module during distance class, as it seems to favor one group over another. Finally, inquiry-based learning using both the physical world and virtual platforms should be studied further and deeper to understand more their roles in the teaching and learning processes. Here are the references, and I thank you for listening. I hope you enjoyed.